All right, so part two. Notice on number 4 I have changed, and this time I don't have vertex form, I have standard form. So that means there's a few things that are going to be maybe a little more challenging to get through on this, okay? So for my standard form, I can still see that the a value is -1, which makes my parabola upside down, okay? But remember, if I'm finding the vertex in standard form, I have to say x equals -b all over 2a. And my -b is -10. My 2a is 2 times -1 or -2. That gives me 5. So if I ever have an x and I need a y, then I'm just gonna plug my x in. So when you're working with it, don't worry about the less than or equal to. That's not an issue until you get to the graphing. So negative, it's going to be 5 squared plus 10 times 5 minus 27. That's going to be 5 times 5 is 25 times that negative plus 50 minus 27. I'm seeing that these are -52 plus 50, so that's working out to -2. So my vertex is at 5 comma -2. So I'm going to plot my vertex, 1, 2, 3, 4, 5, -2. All right. In this one, my parabola is upside down, so that means I could draw my axis of symmetry downward. And a lot of times it doesn't ask you to draw the axis of symmetry, but it does kind of help you shape your graph if you're graphing by hand on the computer. Probably not as big a deal because my math lab makes your graphs so easy. So I remember that an a value of -1 means out 1, down 1, so it's just your normal shaped parabola. Now, before I graph it, I'm going to be careful this time because last time I wasn't so careful. It is an inequality, so I needed to consider dotted or solid. I see that this one's solid. And I also need to consider where I shade it. And so since it's less than, I'm going to shade below. So when I go below my vertex, whoa, that's kind of big. When I go below my vertex, it does put it in the inside of the parabola. So now I'm going to shade the whole inside of the parabola. I think that my highlighting tool's a little too thick there. I might calm that down a little bit. But anyway, there's my graph. Now, I see something that makes me very happy, and that is that this parabola never touches the x-axis. So I get to say no x-intercepts, and I don't have to do any work because a lot of times the x-intercept work is the part that takes the most time. Now, y-intercept, I'm looking at the picture, but this parabola is so skinny that it looks like that my y-intercept is definitely going to run off the screen. So I can't see it. I'm going to have to calculate it. So I know I'm going to say 0, comma. Now remember what you do. Oh, y-intercept, and this one's easy. I'll put it right here. You're going to say y equals -0 squared plus 10 times 0 minus 27. So you're still plugging in 0 for x and then working out y. But guys, look, that zeroes out, the middle term zeroes out, minus 27. So y equals -27. So I want to remind you, we talked about this many moons ago. If you have standard form, that in ax squared plus bx plus c, the c is the y coordinate of the y-intercept. So standard form, the one thing it does speed up is the y-intercept part of the problem. Now let me mention this. Some of you all have not been real crazy about doing the a value stuff. You can always plot your vertex and then plot your y-intercept and use symmetry to plot a point on the other side of the parabola if you like that better than using the a value thing. Oh goodness, look at this one. I've got another problem in standard form, and this one is chock full of fractions. Oh me, oh my, it's going to be difficult. Well, we'll work on that, okay? So the a value on this one is -1/2. That tells me the parabola is upside down. I tell you what. Well, hold that thought. So I'm going to go to Vertex first, and then I'll make the decision I was considering, and I'll fill you in on that in just a minute. So x equals negative b all over 2a. Well, do you see that the b value is 1, so it's negative 1. Now look, 2a is 2 times negative 1/2. Well, that's going to be negative 1 over negative 1, because half of 2 is 1, and positive times a negative is negative. Oh, so I was worried about fractions. They're not all that bad. So I've got an x, I need a y. So I'm plugging my x's in. And this is going to work out okay too, guys, because 1 squared is 1, all right, times the negative 1/2 is negative 1/2, plus 1 plus 15 halves. Look, 15 halves minus 1/2 is 14 halves, and 14 halves is 7. Plus that 1 gives you 8. And you could also plug that in on your calculator and check it out if you wanted to. But that tells me my vertex is at 1, 8. All right. So if I graph 1, 2, 3, 4, 5, 6, 7, 8, if I graph that, the axis of symmetry runs downward since the parabola is going to open upside down. Now some of you, like I've mentioned on the last slide, have been kind of shaky on using the a value, especially when the a is a fraction. So let's do something different. All right. Do you all see that the y-intercept is just 0, 15 halves? Okay. So you might be able to type the coordinates in to get the my math lab to do this, because sometimes you can't plot the points, but it'll sometimes let you click on a point and type coordinates in so you can plot it. Well, I know that 15 halves is the same thing as 7.5. Okay, so if I said 1, 2, 3, 4, 5, 6, 7.5, try that again. That's going to be right here. My computer's driving me crazy, and I'm going to go the no. I'm going to go the other direction, because remember, I should have a point on either side of the axis of symmetry. So then I've got my parabola. Now I do want to mention, okay, on using the a value, if I said I'm going to go out 1, down half of what's normal, and half of what's normal is 1. So that's down a half. That's what I just did. If I go out 2, normally you go down 4, but I've got to go down half of what's normal, so that's down half of 4 is 2. So I could also say from the vertex out 2, down 2, and then out 2, down 2. Uh-oh. What that tells me is I got a little crazy there. My parabola wasn't shaped quite perfect. Let me see if I can shape it a little better. I didn't mean to erase everything. Try that again. So I had these 2 points right there already. Sorry, the computer's acting up. And then I said out 2, down 2 would put that point here, and then one that's 2 units on the other side of the red line would be right there. Now I've shaped my parabola a little bit better. So I'm trying to show you that you can use the y-intercept and the point across from the y-intercept to draw your parabola, or you can use the a value, and those two should agree. So anyway, there's that. So I don't need to worry about shading on this one because it's an equation, not an inequality. I do need to worry about x-intercepts, and I can see from the graph that I do have x-intercepts. Now, I can see that the graph's crossing the x-axis. I don't know where exactly, because you just saw that my parabolas sometimes get a little carried away. So what I need to do is say negative 1/2 x squared plus x plus 15 halves. Remember from our bridge worksheet, when you want to find x-intercepts, you change it from y equals to 0 equals, and there ain't no way I'm dealing with the equation like it's written. So I'm going to clear fractions and clear out the leading negative. So let me multiply everything by negative 2. So negative 2 times negative 1/2 is positive 1x squared. Negative 2 times a positive 1x is negative 2x. Negative 2 times a positive 15 halves is negative 15. And then negative 2 times 0 is 0. Now, I'm looking at it, and I always want to try to factor first. And if factoring doesn't work, then I decide complete the square or quadratic formula. Well, I'm thinking that my AC is negative 15 and my B value is negative 2. So I'm immediately thinking, what about negative 5 times 3? Well, negative 5 plus 3 does equal negative 2. So I could write this in factored form by saying x minus 5 and x plus 3 equals 0. So x equals positive 5 and x equals positive 3. So that should be where I'm seeing the graph cross the x-axis. Well, so let's see here. 1, 2, 3, 4, 5. Well, it's a miracle. That's actually correct on that side. And then 1, 2, 3. Yep, that's right. So me fixing how wide my parabola was in the previous step actually helped me fix, and my x-intercepts look fairly decent, which is not typical for me. I'm usually off. Like, you can usually tell that it's close, but it's never perfect. So that's just beginner's luck maybe. All right, so I'm looking at this problem and see, yes, I do have standard form. So have you noticed that in the first video I did your vertex form problems, and now I'm doing your standard form problems? The A value is negative 3. As long as the A values are integers, it's pretty easy to use the A value for your graphing. That means it's an upside down parabola. X equals negative B all over 2A. So your negative B is negative 42. Holy moly, these are big values. 2A is negative 6, and that gives you, positive 7. Okay, that's maybe not so bad. On this one, I need to say y equals negative 3 times 7 squared. Let me go ahead and put that in. Plus 42 times 7 minus 147. Hey guys, just insert all of this in your calculator right like it is. Okay? And that'll make it a little faster for you. When I insert all that, I'm getting y equals 0, or u. So that puts my vertex at 7, 0. Well, that's a surprise. I didn't expect it to turn out that neat. I thought the numbers were all going to be huge. So 1, 2, 3, 4, 5, 6, 7. That's right here. The parabola opens down, so I'm going to draw my axis of symmetry downward from that. The A value is negative 3. So remember, this says that you go out 1, down. Now, normal is down 1, but I'm going down 3 times 1, so I'm going to go down 3. I'm not saying down negative 3 times 1, because the fact that it's down is what the negative is telling me. So out 1, down 1, 2, 3 would be right here, and that's 1 unit away from the red line. So let me put 1 unit away on the other side of the red line. Now I'm going to be more careful because I about tripped myself up earlier. That says greater than, so that means dotted, not solid. All right, and I need to shade. So when I shade it, greater than means above. So go to your vertex, right? Go to your vertex and go above it. All right, above the vertex in this case is outside the parabola. So I'm going to shade the whole outside of the parabola. This is a little bit more reasonable size marker. And it goes all the way across. Usually, if you're like me, you might just shade part of the thing. Now, the last two things I need to do are easy peasy, because guys, if you look, where does this parabola touch or cross the x-axis? Computer glitches right there. Awesome. Since this parabola kisses the x-axis, I've got a double root. So I don't need to do a bunch of work. I can say that my double root is at x equals 7, or 7 is the x-coordinate of the vertex. If the computer probably wants you to online put a whole point, so it's 7, 0. That's awesome. The y-intercept, now I can't see the y-intercept because it looks like this parabola is going to go way, way low before it ever crosses your y-axis. But I remember that I can just look at my C value, and that's the y coordinate of my y-intercept. So yeah, there's no way I'm going to make enough tick marks to plot 0, negative 147. All right, let's do our last problema. So I notice again I've got standard form. I notice that the a value for standard form is 2. That means my parabola is right side up. I need to do the vertex, so x equals negative b all over 2a. Negative b is negative 20. 2a is 2 times 2 or 4. That's negative 5. I need the y coordinate, so 2 times negative 5 squared plus 20 times negative 5 plus 45. Now, negative 5 squared is positive 25 times 2 is positive 50. 20 times negative 5 is negative 100 plus 45. I notice 50 and 45 adds up to 95, and 95 minus 100 is negative 5. So I'm getting that my vertex is at negative 5, negative 5. Okay? So, let me plot those points. So 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's see here. Axis of symmetry would extend upward from the vertex since the parabola opens up. Let's see, my a value is 2. So this means go out 1 from the vertex, go up. Remember, up 1's normal, so I'm going up 2 times 1. So out 1 up 2, out 1 up 2. That puts me 1 unit to the right of my red line. So let me now go 1 unit to the left of my red line. Okay, it is an inequality, but since it's less than or equal to, it's solid. So let me go ahead and graph a solid parabola. My parabola is going to be decent. It's not going to be perfect. But remember, online, when you do this, once you plot the vertex and one more point, your parabola is perfect. So you'll be able to see a lot better than what I can when I'm graphing by hand. All right, so on this one, I noticed that since it's less than or equal to, I need to go from the vertex, put your pin on the vertex, and when you go below the vertex, you wind up being down here, which is outside the parabola. So I'm going to shade the whole outside of the parabola. Oh, this kind of looks nice this time. Oh, maybe I didn't make it look so nice just then. All right, so let's finish up with our other information. Now, on this one again, it looks like the parabola. I'm looking at Y-intercept. I'm doing the easy part first. I'm being kind of a chicken. So it looks like that the parabola is going to have to stretch way tall before it crosses the y-axis. And sure enough, the y-intercept is 0.45, so that's way too tall to try to plot that point. All right, so x-intercepts. Does the thing have x-intercepts? Yeah, I can see that somewhere in here and somewhere in there. And again, my parabola is not perfectly drawn, so I might be a little off there. But I know general neighborhood that the parabola does cross the x-axis twice. So I need to take my 2x squared plus 20x plus 45. And instead of equals y, make it equals 0. And remember, when you're doing any of the work, drop the inequality. Just make it an equal sign. Okay, so I could do, I don't think this is going to factor, guys. Okay, so, and with numbers as large as, well, I mean, like the AC would be 2 times 45 is 90. And I could go through all my various problems, but I'm pretty sure this doesn't factor. I tell you what, we've not reviewed this in a while. Let's review quadratic formula. This is actually a decent one to do complete the square, but let's review quadratic formula. So x equals negative b plus or minus the square root b squared. 20 squared is 400. Remember, that's always positive. Minus 4ac all over 2a. So remember, what I've asked you to do is get the one number under the square root by itself And when I do that, let's see here. I'm punching it into my calculator. I hope you are too. 400 minus 4 parentheses 2 parentheses 45. Just punch it and write it like it is. That's 40. Okay. So that's going to be negative 20 plus or minus. Now the square root of 40, think about it. I could say that's 4 times 10. Square root of 4, square root of 10, all over 4. And you know what I'm going to do? I'm going to back that up, and I'm going to say over 4 over 4. And I'm going to go ahead and separate and reduce. So that's going to be x equals negative 5 plus or minus. The 2 and the 4 cancel or reduce to 1 over 2. So I'm going to say square root 10 all over 2. So sure enough, since I'm getting messy, weird answers, then it would not actually factor. Now, if I want to find out what this is, let me show you decimal-wise to see how close I was on my graph. If I punch in the square root of 10 on my calculator, so second square root 10, and I divide that by 2, I get 1.6. So this is negative 5 plus 1.6 and negative 5 minus 1.6. Well, that's negative 6.6, and negative 5 plus 1.6 should be negative 3.4. So my parabola should roughly be crossing the x-axis at negative 3.4. So if I say 1, 2, 3, 3, I'm not touching, but negative 3.4 is not bad for this point right here. It's almost on it. And then 6.6 would be 4, 4, 5, 6.6. Other than the fact that I can't write where I mean to write, I can see that that's close to negative 6.6, so that's pretty good. All right, guys, so I've tried to show you a variety of equations and inequalities, some vertex form, some standard form, some where we have nice, neat double roots where you can do the x-intercepts quickly, some where there are no x-intercepts, those are even faster, and some where you have to work out x-intercepts. Sometimes the x-intercepts are neat, sometimes the x-intercepts are messy. And I've showed you how to find the decimal values of the x-intercepts because sometimes that's what's going to ask. And that's it. All right. So I'll see you in my Zoom classroom if you're confused by any of these examples or need help on any of your homework problems.